And now we finally get to graph polar functions. So that means that we need to change the mode on the calculator. So go to mode, make sure it's in radians, then go over here and change to polar. And now when you use this button that says y equals, it's actually going to say r equals. So let me erase this old stuff, type in the new one, which is cosine of 2 theta. So now when you use this key, it's no longer x, it's theta. And for the window, so have theta go from 0 to 2 pi. For the step, that's usually pi divided by 24 to begin with. And then x's and y's. Well, cosine ranges between -1 and 1. So I'm going to put that both x and y range between -1 and +1. And then take a look at the graph, and it makes a nice 4-petaled flower. It's a 4-leaf clover. So part of the directions were graph it. So graphs like this, and then another petal, and the 4 years at art school pays off, huh? It's a nice flower. This one didn't ask for it, but let me just show you one other thing. Sometimes you need this. So I'm going to slow it down. I'm going to put 0.01. And then watch where it starts and what direction it goes. So it starts right here and it goes that direction. So sometimes you need that information. Where does it start and which direction was it going? That's called, these little arrows are called the orientation. Now convert to rectangular coordinates. So this basically goes back to the basic definitions of sine, cosine, and tangent. Except instead of me using opposite, adjacent, and hypotenuse, I'm going to use the letters x, y, and r. Now some equations that I could come up with are, for example, the Pythagorean Theorem. R squared equals x squared plus y squared. I could do sine of theta. Sine is y over r. Cosine, that would be adjacent over hypotenuse, or x over r. And finally, tangent would be opposite over adjacent, or y over x. Now usually these are arranged a little bit differently. The first one isn't. But this one you usually solve for y, so multiply both sides by r, and it's going to say r times sine of theta equals y. R times sine of theta equals y. And this one would be r times cosine of theta equals x. And the bottom one doesn't change. So writing it this way basically separates. This is the x, y system, and this is the r theta system. So if you're bilingual, this is one language, and this is the other language, and this is the little key to translate between the two languages. Now we need to do that with this one. So change it out of the r and theta language and change it to the x and y language. Well, to begin with, none of these say cosine of 2 theta. So I need an identity for cosine of 2 theta. I'm going to use cosine squared minus sine squared. There's actually 3 to choose from. I just happen to remember that one first, so that's the one I'm going to use. Now, if you look at this part right here, it says you need r times cosine. We don't have r times it, also it's been squared. So what I could do is multiply both sides by r squared. So on the left side, it would be r cubed. On the right side, distribute the r squared, so it's r squared times cosine squared minus r squared times sine squared. Well, if you take this equation and you square both sides, you'd get r squared cosine squared equals x squared. So r squared cosine squared equals x squared. And if you take this equation and square both sides, you'll have r squared sine squared equals y squared. So r squared sine squared can be replaced with r squared. And one other thing is, with this equation, you could solve for r. It would be the square root of x squared plus y squared. So on this side, we could just replace r with the square root of x squared plus y squared, and then it's cubed. So we are finished, but let me make one more important point. So there would be a time in, let's say, second or third semester calculus when you're dealing with a function like this, and you're like, oh my gosh, it's got x squares and y squares, and they're not even on the same side, and then this one has a square root and a cube, and my gosh, that's complicated. But this function, if you put it in polar form, is just r equals cosine of 2 theta. So there's going to be times when you're dealing with x and y and you have a mess, you change it to polar, and it's very, very simple. That's the point of that one. Thank you.